Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of functions in Go language. Before I start the discussion, I have to include the main package at the beginning of the program file. Also, I have to import the fmt package so that I'm able to use the printline function coming from this package. Now, let us start the discussion. So, what is a function in Go language? Functions are actually a fundamental building block of Go language code. They can allow us to encapsulate code into the reusable blocks so that we can improve modularity and readability, so we can write programs more easily by using functions to help us replace the repeated code. So let us start the discussion of setting up a function. A typical function has a name and a list of parameters, a return type, and the function body. So in this example, I have the name called greet, and the parameter list has one variable called name of string type, and the return type is here, also a string type. So the return type is the type followed by the end of the parentheses, okay? And the return type is this one, which is clearly a string type, okay? And the return data type is put after the parameter list. So this is the meaning of this sentence. The data type to be returned is put after the parameter list, okay? So when I call the greet function, I'm able to return a string. So how can I use this function that I created? Let us see. You can see here, I can call the function in this way. I can use the function name called greet, and I put a certain string called Alice. So the name here will be replaced by the Alice string here. And the return value coming from the function will be stored in the variable called message. So I'm able to print the message variable to see the content of the function together with the use of the passed variable. Okay, so let us run the program. Okay, you can see hello Alice. Alice is the value that is put into the greet function, and the message captures the returned value from the function called greet. So you will see hello, comma, and Alice. Alice is the name passed to the greet function, and this greet function is able to use the name passed to it to produce a return value that is in the form of a string type, okay, and the message variable is going to store the returned value from the function, okay. Okay, a function can have more than one parameter. What does it mean by this sentence? Let us see the following example. I want to have a certain function called add, and I would like to just add the two integers passed to the function. So I can put a and b here, separated by a comma, shown here, okay. And since both a and b would have the same data type called int, I just use int here once only to indicate that both parameters would have the same data type, okay. So here is the meaning of this sentence. If two neighboring parameters are of the same data type, we can declare their type once only. So a and b are neighboring to each other, and I can just use one data type int to declare the data type of both a and b, which are neighboring, okay. And of course I have to declare the return data type of the function, which is an integer. So we have to notice something here. If a and b here are of different data types, we have to really declare the data types individually for each parameter, okay. But now, since I want to use integer type for both a and b, I can just declare it once only. And the return value is just a plus b. So I just put two numbers into the add function, and I'll just add the two values, and I will get the sum of the two numbers. So how can I call it? I can use this idea. Add 3, 5, and I will store the return value into the result variable, and then I'm going to print the result variable. So I will have 8 coming out after the use of the add function that I created. So let us see the result. Yes, you will see 8 here because I just do 3 plus 5, okay. Okay, let us talk about another example of functions. A function can return more than one value. So in the previous two examples, I just returned one value from each function. But it is possible to return more than one value. So how can I do so? Let us use the following example to explain the idea. Since we want to return more than one variable, we have to declare the data type of each return value clearly. And we have to include a pair of parentheses in doing so. So you can see that after the parameter list here, I have another pair of brackets to indicate the return data type for each of my return values. So a plus b is an integer and a minus b is also an integer. So since a and b are both integers, I just need to declare the type once only, and this is the shorthand form of writing the declaration because a and b are neighboring to each other. Okay. So when I call the function, I can just say answer1 followed by answer2 to absorb the returned value from the function directly. Okay, since the return value has two results, I have to use two variables to really obtain the return value from the function. Okay, and of course I can just print the content out because each of the variables is just getting the result coming from the function. Okay, so let us see the result. Okay, you can see 9, which is the sum of 7 and 2, and the second answer would be just 5 because it is just 7 minus 2 from the second return value of the function. Okay. Okay, we can also create a function that has the following characteristic. We can give a name to the return value of a function. So I'm going to give the name of the return value as area shown here in the function body. Okay, and then I can just use the return keyword directly, and the area value will just be returned to the function. Okay, and the return data type has a variable name before it. So you can see that when I use area in the function body to become the return value of the function, I have to indicate the variable name area here in the return type portion of my function declaration. Okay, area is the name that I'm going to return, and it is of float64 data type. Okay, and length and width are both of float64 type. Okay, and when we type return here, the named variable will be returned. So when I type return here, the area value will be returned. So when I call the function, I can just say the function name followed by the two numbers that will be passed to the function. And when I run it, I'm able to indicate that the area will be returned, and this area value can be printed immediately. So let us see the result of running this program. Okay, you can see that 12 has come out because I'm doing 3 times 4. Okay, so area is the value that stores the return value from the function body, and when I use the return keyword, this area value will be returned by the function to the outside world. Okay, and when I use the return keyword here, the rectangle area value will just be the length times width coming from the function body, and it will be printed out in the function call. Okay. Okay, let's talk about another function type called Variadic function. So the word Variadic means that the number of arguments to be put into function can be variable. So we can have different number of function arguments to be put into the function. So how can we achieve this kind of function? Let us see the following example. We can accept a variable number of arguments by using 3 periods joined together. And these 3 periods are called ellipses. Okay, and the parameter is a slice that stores the argument. So here the parameter is really a slice that stores the arguments of variable length. So you can see that we have a pair of square brackets to indicate the slice, and in this slice each content will be of integer data type. int, okay. And I have to use 3 periods before the data type to indicate that I have to create a variadic function that accepts a variable number of arguments, okay. And the return type is an integer in my case. So I can input a number of numbers, and then I want to get the sum of these numbers, regardless of the number of elements being put into the function for each time. So in the function, I have a local variable called total, and I can just loop over each number from the numbers slice shown here. So I just pick up the slice content one by one, and each number will be stored in the number variable, and I add the number to the total variable, which is going to store the sum of all the integers, okay. And then I just return the total variable to the outside world after the for loop. So I will get the sum of all the numbers in the function arguments, okay. So how can I do so? Let us see the example here. I can do sum 1, 2, 3, 4, 5. Then I can use 5 function arguments to run the variadic function. Another way of calling the variadic function is to pass a slice to a variadic function. So you can see that numbers is really a slice. So in principle, I can just input a slice into the function call directly. So you can see that I have a slice called my slice, which is a slice of integers. So I have 3 integers stored into the slice, and then I can just do sum my slice followed by 3 periods to indicate that the my slice variable is really trying to handle a variable number of arguments in the function call, okay. So let us see the result of using these 2 approaches to call the variadic function. Okay, for the first call, I would get 15 because I'm just able to add 1, 2, 3, 4, and 5 together. So this is the first approach of passing independent numbers into the function. Okay, and the second way is to use a slice as the input variable of the function call. So when I input 1, 2, 3 into the slice, and I use the slice in the function call of the sum function, I'm able to get 6 because 1 plus 2 plus 3 is just 6, okay. So these 3 dots would try to indicate that I'm handling a variadic function, okay. Okay, we can also declare the functions in a structure. What does it mean by this sentence? Let us see the following structure. So I have a calculator structure, and I have 2 fields for this structure. One is called add, another one is called subtract. And you can see that the data type of these 2 fields would be of function type, because I indicate that add is a function and subtract is also a function. And add has to input 2 arguments, and subtract also has to input 2 arguments. And the return type of the add and the subtract functions would both be integer. Okay, so you can see that the fields of this function are just 2 functions, okay. And how can I really create an instance from this structure? Let us see. A function can become a structure field, as I said, and we can define the functions when we really make an instance. So you can see that when I just declare the structure, the add and subtract functions would have no implementation detail. But when I really create an instance, I can really set up my detail of the 2 functions. So the 2 functions in this example are called anonymous functions, because you can see that when I want to implement the add and subtract functions, I don't have a name to the function, okay. So when we use func here, it means that the add variable is a function, and the function has 2 parameters, a and b, which are both integers, and the return type of the add value would be of integer type. And how can I implement the function? I just do a plus b. Similarly, I can do the same thing for the subtract variable, and the subtract variable would also represent a certain anonymous function. And this anonymous function needs 2 input parameters, and it will return 1 value, okay. And the value we returned is just a minus b, okay. And after that, I can just use the function fields to help us get the sum and differences of two functions. How can I do so? I can just use the instance followed by the field of this instance called add. And since add is really representing a function, I can put two arguments into the add field, 10 and 5. And when I use the add field here, it means that I'm doing the addition shown here. That's why I'm able to get the sum as 15 when I call it. Similarly, I can do the subtraction by using 10 and 5, which would follow the subtract field of the calculator instance. Okay, so let us see the result of running this part of the code. Yes, 10 plus 5 is 15, and 10 minus 5 is 5. So we can see that we can use the definition that is created when I set up a certain structure instance. Okay. So this video has discussed a lot of things about functions. We can set up a function that has one parameter, and I can set up a function that has more than one parameter, and I can return more than one value out of the function. And I can also give a name to the return value of a function, and then I can just return the name to the outside world when I call the function. And I also mentioned Variadic function that accepts a variable number of arguments by using the 3 periods here. Okay. And we are also able to declare the functions in the structure by indicating the implementation detail of the functions when I just want to make a certain object from this structure. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.